But I'd like to introduce Colin Sullivan, who's our head of product at Synadia, and he's going to be talking kind of about where we're at and where we're going. So welcome to the stage, Colin.
Hi, thanks, Jeremy. Yeah, thank you very much, and thank you all for your time. I'll talk a little bit about where we're now and a little bit about how we got there and then where we're planning on going. We've already touched on a lot of this, but let me just set the stage and talk about things really high. I promise my presentation won't be all numbers here. So if we look at the distributed cloud computing market trends, and we look at cloud, we have a CAGR, compound annual growth rate, of about 12% over the next several years. So it used to be higher, it's shrinking a little bit, but where we're seeing the additional growth is in hybrid, which is about 20.6%, 20%, and edge even higher at 30%. So we're still seeing expansion in cloud. We're seeing much more expansion in hybrid, which is cloud and on-prem or multi-cloud, and edge. And where does NATS fit into this? Well, the very cool thing is NATS fits in any of these. Being a single binary, no external dependencies, we can run about everywhere. We can run on a Raspberry Pi, we can run in the cloud, run on premise, run on VMs, bare metal, what have you. And that means, and then also in terms of what we need as far as network, we just need the basics. We just basically need TCP. So given those two primitives that we have, we can tie together cloud, on-premise, edge. We can run in any one of these. We can run in all three, or any combination thereof. So if you look at this, this is a really high topology view of what NATS can do. Every one of these is a real use case for NATS. Whether we're going over 5G, we're out in retail with leaf nodes running in restaurants and stores, coffee shops, sending data back, running in clouds, tying different clouds together for companies that have policies that require them to operate across multiple clouds. And we are even in space, we're on factory floors. Some very, very, it's been really exciting to see how far NATS has gone and where we're running today. Some really cool use cases. I promise I will go down into technical, but I just wanted to talk a little bit about the biggest problems we see, the macro problems and the concerns, which are speed of innovation, time to market, total cost of ownership, and vendor lock-in. These tend to be the biggest problems we see. Most of Synadia's customers and most of NATS users end up using NATS to solve issues in one of these areas. So via NATS reduces complexity. We've already talked quite a bit about, with a single deployment, I can have a stream, I can have a KV store, I can have an object store. I've got one single technology going all the way from the edge to cloud to on-prem. I'm not having to glue a bunch of things together. This spurs innovation. You can do things faster, you can develop faster. Your applications are very simple. We have a very simple API. You write a simple application on your laptop, I have to change one URL, and the same thing can run in the cloud, on the edge, wherever. This results also in faster time to market and ultimately lower total cost of ownership. You only have one technology to administer, to monitor, to deploy. In connectivity and storage, we eliminate the vendor lock-in problem. When you're using a KV store, you aren't necessarily locked into a particular vendor. You are using NATS, but that KV can live anywhere. Object store, if you have the NATS object store, you don't necessarily have to use a particular cloud's object store. And between storage and connectivity, there's no vendor lock-in. I can write my NATS applications, I can set up my NATS configuration, and for a large part, if I needed to, I could just move that from one cloud to another, move that from on-premise to cloud, basically changing host names, some configuration as well, but the applications wouldn't have to change a bit, again, other than where it connects. We have observability. The advantage of a single data plane, a single technology, results in lower TCO. And then also with observability, being able to see all these components together at once. We've had some of our Synadia customers derive some great insights into business, into what happens at certain times a day. They're able to head off ahead of time. Hey, I'm going to have to scale in this particular region. I might even want to scale ahead of time if I've got a product launch that I know there's going to be a lot of interest or downloads or signups. In terms of scalability, we reduce total cost of ownership and faster time to market. Byron and Jeremy have already demonstrated how easy it is just to increase applications, being part of a queue group, participate in that. And remember, that was no configuration. It was just launching additional applications. So at any time, if I find I have to scale, I can just scale up and then scale back down. And that's have some APIs that make it very easy to scale down as well, so you don't lose any data. And then also faster time to market. So again, scalability isn't a configuration issue. You may want to throw some more hardware at it, but in terms of software and NATs, it's just launching more instances. And then performance and latency. A lot of users may not necessarily need 20 million messages a second. And we get that, but what that translates into is I can do a lot more with less. So I can provision machines that are a little bit more insufficient today, and I won't have to re-provision for years. Where with other technologies, you might be at the edge of that machine in order to reduce your costs, and you'll have to scale more quickly. And finally, with faster innovation, faster time to market, one thing, it sometimes takes a few conversations, but our multi-tenancy in security allow operators to look at the system and put guardrails around what the development teams are doing. So I can set up an account with a specified number of connections, specified number of subscriptions, number of high availability assets that are available to Jetstream. And I know that development team won't exceed that. They won't necessarily create that noisy neighbor problem. That allows that development team to really push things, allows that development team to operate in their own sandbox. And I don't have that fragile system that I'm afraid to touch. Just let them go do what they need to, and that allows them to innovate faster. Fewer meetings with operations. Can I get these resources? And ultimately, faster time to market. So one of the things I like to think about with the evolution of NATs are NATs layers. So we started off years ago with the NAT server. It was a single server, ran over TLS. There was no, or TCP, there was no TLS at the time, and it was written in Ruby. That was a very, very first incarnation of NATs. We rewrote it in Go. When I started contributing to NATs, we were just starting the cluster. I remember Derek just put in clusters. And then we added leaf nodes, super clusters, and this is your communication. I like to think of this as where data can go. This is like your electrical grid. Data has the potential to go everywhere. But then we add security on top of that. Initially, we had username, password. Now we're using JWTs, JOTs with ED25519 key signing, so we can do things like the NAT system never ever has to read or access a private key. And we can also do identity mapping with X509 certificates for TLS. The little layer above this is the multi-tenancy and sharing. And this got us really far. This is really cool what we were able to do. So communications ultimately is like your power grid, where everything can go. Security are your switches. Where am I going to allow things to go? What data am I going to allow to share where? And what we've done over the last couple of years is add persistence. So this is your Jetstream, your streams, key value store, object store. But we've gone a little bit a step beyond. We've realized that this data needs to have mobility. We need to be able to move a stream. We need to be able to replicate a stream to be able to have it closer to your application. We want to be able to aggregate streams, aggregate key V stores, or mirror a subset, as Jeremy and Derek were just talking about. And then I'll leave it to you as the viewer and participant to extrapolate what might come next. But we do have some really cool stuff we're thinking ahead. Today, just to go over a roadmap real quick, we have GA'd the essential KV store. We have tag-based stream placement. So I can put tags in my NAT servers. I can say, put this stream here, and that stream will be placed on NAT servers with those particular tags. Very useful for GEO, GPR. Stream migration, we have replicas scaling up and down. At any point in time, I can take an R1 stream, turn it into an R3, back down to an R1 as I need to. We've got stream publish, which is a scalability play. Subject hash partitioning, Jean Noel did that, where you can take a subject, partition it into several other subjects. for ordered processing of messages spread across. And then consumer replica and store options. But where we're really leaning into, we've already seen a lot of questions about KV store and scalability. We're leaning heavily into KV improvements and large consumer sets around performance. So particularly with KV, we want to get to that billion key capability, and we're working towards that. We have KV mirror support. You've seen a little bit of this, where you have a single source of truth someplace, but your mirror where you can access your keys very close to you. And large consumer sets. When we first created Jetstream, we kind of figured, well, people are going to use durable consumers. They're going to want to consume data in a durable way, and they might have a few thousands of these. We've seen users want 30, 40 thousands. So we're going to be doing some work along optimizing for large consumer sets. Surveyor Jetstream support. We've got an object and KV store API. We're coming up with a new Jetstream API. Not necessarily a replacement, long-term it will be, but a simplified API. When we built Jetstream, behind the scenes, under the hood, Jetstream is very complicated. If you look at what's going on in the NAT server, we do a lot of really complicated stuff for you. And I'll own this. Unfortunately, some of that was reflected in the API. We're going to make this new API that's it's available right now in some areas as beta and experimental, but just a very, very easy way to access these streams, key value stores, to consume data in Jetstream. We're working on a service API, experimental. It's going to think about the concept of what if you could write your service with just a couple lines of NATS code, but that service would have health endpoints, and I could figure out my service is healthy. I could pull it for statistics. I can maybe even eventually do some command and control things with it. We're writing a service API to let you do that. And then by popular demand, we have server callouts. So authn, authc tied into authn. So the ability to give NAT something, a credential, a token, what have you, and call out to a different process. And that process would mint credentials that make sense for NATs. We would also have callouts for generalized message flow. So these are schema validation, data scrubbing. Maybe I want to evaluate every message and scrub PII out of it. Or data enrichment. Every message coming from this account, I'm going to add a header. A lot of different things you can do here. First half of next year, it'll be largely transparent to applications and developers, but we're going to rework networking for long-haul connections, and then also rework networking for hub and spoke. So we talked about clusters and superclusters. Imagine multi-connection gateways between these servers to better utilize these long-haul connections and get better performance out of it. Also, a bit better resilience. With hub and spoke topologies, imagine I could have a general backbone that runs on a single cloud or runs on premise, and extending from this backbone, I can have superclusters extended out of that. It's another topology that lets me better utilize the resources I have. In terms of leaf node enhancements, we're looking at compression on leaf nodes. So, we talked about I run a leaf node on my laptop. Anytime there's interest elsewhere connected in NGS, if I publish a message to something that's interested in NGS, that message will go over my Wi-Fi connection on my laptop to NGS. Well, if the leaf node automatically compresses that data before it goes out, and then data decompression happens at the application, I'm able to use a lot more with a lot less of my resources. I'm able to get a lot more out of my Wi-Fi connection. We're going to do the same with encryption. So the ability to have a leaf node potentially set up keys, so as data leaves my security context, it's encrypted. The general NAT system cannot see that payload, and then it's decrypted on the other side. Again, making things very easy for you as a user to do this. You won't have to worry about the complexity behind setting this up. We'll do as much as we can automatically for you. And then some extreme scale, extremely lightweight stream consumers. This is more along the lines of IoT, but we're talking about millions of consumers. And then as we get to the second half of next year, we're going to look at extreme scale interest graph partitioning. I want to individually address 1 billion endpoints. hundreds of million of endpoints. Those are the problems we're going to be trying to solve. We're going to look into schema management and service registry. So again, these are these server callouts. We might provide some basic NATS examples as to how to do that. And I'll get to a little bit about what Synadia might offer in that area as well. And as Derek mentioned, we're going to be looking at attractions. So what if my application is accessing a stream or KV store, and I want to move my application? Let's say my application is on a truck and I'm in the Midwest. I'm connected to a cloud and I'm accessing a KV store in the Midwest, but I want to configure a weight and attraction to that KV store. And as I move to the West Coast, that KV store is automatically migrated to the West Coast. So from my perspective in an application, my latency, no matter how far away I get from where that originally was, my latency will remain similar because that has been moved. We've talked a lot about services, and I just want to share. A couple of years ago, we took a good look at Service Mesh. A lot of people loved it. A lot of great features in Service Mesh. So over time, I'm not going to go through every single one of these, but if you look, you'll probably be able to see a lot of these have shown up in our demonstrations today. So we made the decision to not necessarily chase features, but allow you to provide the same behavior through NATS. So with discoverability, it's kind of that's a no-op for NATS. Once you're connected, you're available. We're going to do things with a new service API around that. Built-in load balancing, traffic management with subject-based delivery. We've got canary testing, and Byron and Jeremy just demonstrated that with subject mapping. There's a lot of things that are built into NATS that Service Mesh has, but the big difference is NATS, you don't need Kubernetes to do it. This is all built into NATS. And I just want to say, I'm going to make a controversial statement. Service Mesh is a awesome technology built by super smart people, but it was built to solve a fundamental communication problem, a fundamental design flaw, which was point-to-point location-based addressing. And because NATS doesn't have that, we're able to do so much more built into the NATS system. Now, NATS runs great in Kubernetes. Many of our users run NATS in Kubernetes, and they love it. But at the same time, we can bridge that Kubernetes deployment to leaf nodes. So that's how you might get communication from a vehicle into a Kubernetes cluster. And we've also worked with the Rancher team, with K3S. And NATS is now an option to be the state machine within K3S. So replacing etcd. So what that means is if I choose to leaf node into every single one of my remote K3S deployments, I have observability and command and control from a central place in NATS. So I suddenly have pretty much fleet management for free. There needs to be a lot built around it. It's a potential, it's a thought experiment, except that it is very real in that you have NATS, you have the capability to do this remotely. I can change KV values, which ultimately changes the state in these K3 instances. And there's some very, very cool stuff we can do.
Awesome. Colin, this is so much cool stuff. And I know we have a bunch of other presentations that are going to be showing a lot of this off. And so I know this is probably our last slide, and we're going to be sharing out these slides with everybody. But you want to speak, really quickly to, Synadia's support of open source software, because I know we did get some questions about it. And then we'll move on to Alberto, who's going to show us our services API that we've been working on.
Absolutely. All right. So you're starting to play the music. Okay.
Yeah. This is my idea of playing the music.
So very quickly, Synadia has provided over 100,000 hours of engineering hours, many millions of dollars invested into NATS. So if you do find value in NATS, we just encourage you to give back to the community. There's many ways to do it via awareness, blogs, social media, speak at conferences, host meetups. Of course, contributions are always welcome, especially integrations and other technologies. And then expertise. If you know NATS and you're on our Slack or see issues or anything in Stack Overflow, certainly help out. We'll share these later. Synadia does have some commercial offerings. And I just wanted to thank you. And sorry, Jeremy, for going over.
That's okay. If I have any roadmap questions, if we have time at the end, I'll pull you in to answer some Q&A. So be sure to stay in the room, and we'll work with you there. Thank you so much,